So welcome everybody to this latest video on 162 Maths, and in this video we'll be continuing with the theme of solving quadratics graphically with the idea of being able to draw a diagonal line rather than a horizontal line. Now in the last video we looked at how to solve a quadratic equation graphically when the equation was equal to a whole number by drawing a horizontal line through this number on the y-axis and noting the solution as the x-ordinates of the intersection points. An incredibly long sentence. So for example, here we've got the equation of x squared plus x minus 5. So if I wanted to use this graph to solve x squared plus x minus 5 equals 3, let's say, then all I need to do is draw a horizontal line through 3, preferably with a ruler, which I do not have. And then what I then want to do is project a straight line downwards, and where those arrows face on the x-axis, which is here, and this is the y-axis, this would be the solution. So here the solution would be x equals, I would say, minus 3.3, and looking at the second value, around 2.3, let's say. If I had x squared, let's use a different color. So let's say if I had x squared plus x minus 5 equals 0, well then if I just get rid of all of these, then for this, all I'd need to do is draw a horizontal line through 0, which is basically the x-axis, and the solutions would be where these 2 points here are. So that would be, I would say, x equals minus 2.9, let's say, and the second value would be, let's say, 1.9. And if I had x squared plus x minus 5 equals minus 3, let's say, so then I'd be drawing a horizontal line through minus 3, and I'd be then looking for x equals minus 2 and x equals 1. It's a nice whole numbers there. Now whenever you are doing that, please do make sure that you are drawing your horizontal lines. Don't just simply use your finger, because that in itself would get you a mark within itself. Now in this video, what we're going to look at is we're going to look at what happens when the equation equals another algebraic function. So for example, what would I do if I had x squared minus x minus 5 equaled, let's say, 3x plus 2? Or if I had, let's say, let's just get rid of that. If I had 3x squared plus 4x plus 3, how do I then go about using my graph or solving it algebraically when I have the quadratic equation equal to another algebraic function? Now often there are going to be one of two scenarios that you could face in your exam related to this particular situation. Now the first one is when the quadratic equation is already drawn for you and you need to draw a line, either horizontal, diagonal, or even in extreme cases a quadratic, and then you need to write down the x-ordinates of any intersection points between what's already been drawn and what you have drawn. Or what you could have is you need to make the entire equation equal to 0 and then plot the new equation on a blank set of axes and state the values of x where the curve crosses the x-axis as you've made the equation equal to 0. Now these are two different situations. I would say in an exam you'll only ever get one or the other. You will definitely not get both, as it's too repetitive in terms of expected knowledge that they're going to be asking for. So let's have a move on to an example where this is going to be the case. So looking at example 1, it says that here is the curve of y equals x squared plus x minus 5, and we want to use this graph to solve 2x plus, where the x squared plus x minus 5 equals 2x plus 1. So let me first start by labeling this equation here. So we've got x squared plus x minus 5. Now just like we did in the other video when we had it equal to a whole number, what we've got to do here is we need to plot one line which is x squared plus x minus 5, which is already drawn. And then we also need to plot the right hand side, which rather than being a horizontal line, we now need to plot y equals 2x plus 1. Now to plot y equals 2x plus 1, what we need to do is we know it's going to be a diagonal line because we've both got x's and y. So if I start by drawing a table of values, and I use x values that I can see on my diagram. So I'm going to use the simple values of 0, 1 and 2. Now just as I showed in the video when you're plotting diagonal lines, in theory you only need 2 points, but I would say it's always good practice to have 3. So here we've got 2x times 0 is 0, plus 1 is 1. 2x, so 2 times 1 is 2, plus 1 is 3. And 2 times 2 is 4, plus 1 is 5. So if I then plot these points, I've got 0, 1, which is here, 1, 3, which is there, and 2, 5, which is here. What I now need to do is join those points up with a straight line. If I start by joining these up, now this is going to be a little bit time consuming as I'm not doing this on paper. And you want to make sure that your line crosses the curve through the axes that you've drawn. So here you can see I've got 2 intersection points. Now here the answer equals the x ordinates of the intersection points. So the intersection points are here and here. All I need to do then is find the x ordinates. So in this first one, it's at -2. So here the answer then is x equals -2 or x equals 3. And that would be my final answer. Now the same question but worded differently. So it says here, by drawing an appropriate curve, solve x squared plus x minus 5 equals 2x plus 1. So the first thing we want to do here is rearrange this and take it over to the other side to make it equal to 0. So here I've got x squared, then I'm going to end up with plus x minus 5, and then I'm going to subtract 2x and minus 1. And that's then is all then going to equal 0. So now if I neaten up all of this, then what do I get? Well, I get x squared minus x minus 6 equals 0. So now what I now need to do is plot this equation. Now, looking at the table, typically what you do is then have to draw a table of values. So let's just go for let's go for 3, -2, -1, 0, 1, 2, and 3. Now, a much easier way of doing this then, just to speed up time. Now, I could obviously, without a calculator, we can easily work this out. So this first value is going to be -3 squared minus -3 plus -6. So that's going to be 9 plus 3 minus 6, which is going to be 12. Take away 6, which is 6. And then the next one, I've got -2 squared minus -2 minus 6. So that's going to be 4 plus 2, take away 6, which is 0. And then filling in the rest, I should have -4 -6 -6 -4 and 0. So then plotting these coordinates, at -3 I've got 6, which is there. At -2 it's 0. At -1 it's -4. Then at 0 it's at -6. Then at 1 it's at -6. And then if I then fill in the rest, I then get that. So then drawing the curve, which is going to be not very neat, but is going through all the points, I should have something that looks like this. And you can see from this that my answer is therefore going to be -2 and x equals 3. So you can see how by doing a different method, I still get the same answers, but again, it's just working through it. So it's just a case of devising a new quadratic equation that gives me the same solution as I did here. Now, definitely for higher GCSE, solving any quadratic equation when one has been drawn for you. Now, sometimes you may get asked to use the drawing of one quadratic equation to solve another. Now, this is possible because all quadratics are either positive or negative parabolas. So usually it's going to be a U shape or it's going to be an N shape. Now, there is a way in which you can manipulate a quadratic parabola to be able to sort of resemble either through transformations or through simultaneous equations to be able to then go on to use that equation to solve other quadratic equations. So let's try and make sense of this. Now, there is a general method in which to do this. So step one is you write down the equation you wish to solve. Leaving a space underneath, write down the equation that has been plotted. Then in the space in between, write down the difference between the two equations from new to old, or the required to given. Then make the difference, including the signs, equal to y, and then plot this equation against the quadratic equation drawn or given, and then the solution will be the x-ordinates of any intersection points. Now, if this steps do make absolutely zero sense, do not worry, because we're about to go through an example in which we use each of these steps. So let's have a look at this question. So this question says that we have been given the diagram that shows y equals x squared plus x minus 2. So let me just label this graph here. So I've got x squared plus x minus 2. Now we want to use this curve, or this parabola, to solve a completely different quadratic equation. Now this is the one that's been plotted or given, let's say, and it's also the one that's given, and it's also our old equation, or the original. And this equation here, which is the one that we actually want to solve, is the new equation. It's going to be what we're aiming for. So if you follow the steps, the first thing we want to do is write down the new equation that we want. So we want to solve x squared plus 2x minus 5 equals 0. Now don't worry too much about the 0. Let's just look at the expression. So then I look at the one that's been plotted. So I've got x squared, and leaving a bit of space, plus x minus 2. Now what I want to do is, what do I need to do to get from this to this? So it's from new to the old one. What I want to solve to what's been plotted. So from this, you can see the x squareds are still the same, so that's fine. I need to lose an x, and to get from minus 3 to negative 2, I need to add 3. So that's the difference from this equation here to the one that is plotted, is minus x plus 3. So if I get from this to this, then that's going to be fine. Now this is the equation that I actually want to plot. So I make this equal to y. So I've got minus x plus 3, and I want to plot this. So then from this, if I know it's going to be a diagonal line because it's just got a single x and a single y. So if I just pick three numbers of x, so let's go for 0, 1, and 2. So when x equals 0, that's going to be 3. When x equals 1, I'm going to end up with minus 1 plus 3, which is 2. When x equals 2, I'm going to end up with minus 2 plus 3, which is positive 1. So then if I plot these coordinates, so 0, 3, which is here, 0, 1, 2, which is there, and 2, 1, which is here. Now what I then want to do is join those points up. So if I start by, let's use a different color, let's do for pink. Hopefully that shows up a little bit better. And if I join those points up, make that a little bit neater. And what you want to do is you want to draw the line so that if it can cross the curve twice, that it actually does. So you want to basically extend your line so it hits or goes through the whole entirety, as much of the axis as possible. So as you can see, I've got two intersection points. I've got an intersection point here, and I've got an intersection point here. Now one thing I did forget to do is label this line. So y equals minus x plus 3. And then what I then want to do is project downwards of what these values are. So this is going to be the solution to this equation here. So the solution I get is that x is going to equal, I'm going to go for minus 3.5, or that x can equal 1.5. And again, if you've done this neatly, your answer might be slightly off, but as long as you're basing your answer based on your diagram that you've drawn, that's going to be absolutely fine. Obviously, there's going to be a perfect answer, but there will be a margin of error that the examiners allow you to get for you to access the full marks. So let's have a look at some practice examples without actually having to draw the graph, as they are very time consuming. So let's say in the first column, this is the equation that's been plotted for you on a graph. The second column are the actual quadratic equation you need to use the graph to solve. And then we're going to work out what it is, which line you actually need to draw to then find the intersection points of the x-ordinates. and then you can that would be your answer. So this is what we're given in terms of the first column. So what I want to do is I need to go from new to old, which is the area. We don't want to get this the wrong way around because it will have disastrous results. So we want to go from here to here. So from this, what we then want to do is think of the difference between this middle equation to this, ignoring the equals 0 and ignoring the equals y. So in the first example, I want minus 6x, but I want to get to positive plus 5. So what I need to do is I need to add 11 x's. Then to get from minus 8 to positive 3, I need to add 11. So then the equation I need to plot is y equals 11x plus 11. So it's going to be y equals 11x plus 11 is what I need to plot. For the second example, I want to go from x squared plus 6x plus 2 to x squared plus 3x. So I want to go from 6x to 3x. So I need to lose 3x's. And I want to go from positive 2 to plus 0. So I need to take away 2. Then the equation I then need to solve is going to be y equals minus 3x minus 2. For the third question, again, looking at the x squareds, that's fine. So I want to go from minus 2x to no 2x. And let me just rewrite that. So I've got no x's. So then that's going to be, I need to add 2x's to that, so plus 2x. And I want to go from 10 to minus 8. So I need to take away 18. So then the equation I need to plot is going to be y equals 2x minus 18. With the fourth example, again, I want to go from positive x to minus 3x, so I need to take away 4x's. And I want to go from minus 1 to positive 3, so I need to add 4. So the equation I then need to plot is going to be y equals minus 4x plus 4, or if you want to make it look more aesthetically pleasing to see, you can label that as 4 minus 4x, whichever floats your boat. Then for the last example, again, I've got x squared to x squared, that's fine. So here I need to gain 7x's, so that's going to be plus 7x. And then I need to go from minus 2 to minus 15. So I need to take away 13. And so the equation I'm then going to plot is y equals 7x plus 13. Then obviously what you then need to do is plot these straight lines, these diagonal lines, whether it be with a positive gradient or negative gradient, and then remember your answer are the x ordinates of where the two lines or the curve and the straight line intersect, and that's what you need to look for. But always make sure that you are drawing the lines on your graph. Don't just visualize it, don't just guess, make sure you do draw the line on your graph neatly with a ruler, and you'll be absolutely fine.